This lesson is on limits with factoring. So let's take a look at our first example. We are going to look at the limit as x approaches 3 of 2x squared minus 5x minus 3 over x minus 3. And the first thing we'll check is if we plug in 3, what do we get? So let's take a look. If we just plug in 3, we have 2 times 3 squared minus 5 times 3 minus 3 on top. And we have 3 minus 3 here. 2 times 3 squared, 2 times 9, minus 5 times 3 is 15, minus 3 over 0. We get 18 minus 15 minus 3 over 0, which is 0 over 0. So what does that tell me? That tells me there's a chance this has a limit. So we're going to go ahead and try to evaluate this limit. How? We're going to do it symbolically by trying to factor. So I am looking at the trinomial in the numerator. And I'm going to factor, or at least try to factor that trinomial and see what happens. So you'll recognize right now, 3 is not in the domain. If I graph this function, there is no value when x equals 3. So 2x squared here, negative 3 here, minus 5x in the middle. 2x times x is x squared. I think I need a negative 3 here and a positive 1 here. 1 times 2x is plus 2x, negative 3 times 2x, excuse me, 1 times x is positive 1x. Negative 3 times 2x is negative 6x. 1x minus 6x is negative 5x. So factoring this, we get 2x plus 1 times x minus 3. So this limit will be the same as the limit as x approaches 3 of what? Upstairs, 2x plus 1 times x minus 3, downstairs x minus 3. Again, I want you to recognize 3 is not allowed. If I graph this, I would not see a value with 3. However, that x minus 3 divides out. And now we have the limit as x approaches 3 of 2x plus 1. This is a polynomial. It is continuous. I can plug the 3 in and say 2 times 3 plus 1, 6 plus 1 is 7. So let's check that. I want to first check it on the graphing calculator, if I can. So I'm going to put the function in my y equals. So 2x squared minus 5x minus 3 is in the numerator, is upstairs. Divided by downstairs is x minus 3. And I want to see what happens as I get closer and closer and closer to 3. Look at the table. There's something there. Let's clear that out. Make it automatic first. Create a table and then make it ask. And I can plug in my own numbers. Second table. And I want numbers near 3, 2.9, 2.99, 2.999. What do the values of the functions seem to be getting closer and closer to? Seem to be getting closer and closer to 7. How about from the right? 3.1, 3.01, 3.001. Indeed, they seem to be getting closer and closer to 7. However, if I plug in 3, remember 3 was not in the domain, I'm going to get an error. So that would not show up on the graph, but that is the limit, because what happens at 3 is not the issue. It's what happens near 3 that we are interested in. Okay. We certainly could look at a graph of this if we wanted to. We could say zoom standard maybe. And as we get closer and closer and closer to 3, and it's not really the best window. We can go to zoom decimal maybe and then adjust the screen from there. I need to have more y values. So I will change the y max to 10. And notice we have that hole there. The hole shows up on the graphing calculator. But as I get close, for example, trace at 2.9, you can see the y values are getting pretty close to 7 from the left as well as from the right. Okay, let's take a look at another example. We'll look at the limit as x goes to 0 of x cubed minus 2x squared plus x divided by 2x cubed plus x squared minus 2x. So if we do our first strategy, which is just plugging something in, if I plug the 0 in, what do we get? We get 0 cubed minus 2 times 0 squared plus 0 over 2 times 0 cubed plus 0 squared minus 2 times 0. We get 0 over 0. So that gives us a chance to have a limit. If it were 1 over 0, there's no limit. But if it's 0 over 0, we have a chance to have a limit. So we're going to try to factor to see what happens here. Okay, so what can I do? Well, the first thing I'm going to do is I'm going to recognize there is a common factor of x on the top and the bottom. Limit as x goes to 0, factoring out that x. Upstairs, I am left with x squared minus 2x plus 1. Downstairs, factoring out that x, I'm left with 2x squared plus x minus 2. And remember, 0 is not in the original domain, but that divides out. So now I have the limit as x goes to 0, x squared minus 2x plus 1 over 2x squared plus x minus 2. You may want to factor again. However, let's check to see if I have an answer currently. So if I plug 0 in the top and the bottom, what do I get? Plugging 0 in the top, we get 0 squared minus 2 times 0 plus 1. 0 minus 0 plus 1 on top, I get 1. On the bottom, we get 2 times 0 squared minus 0 minus 2, which looks like that would be 0 minus 0 minus 2, negative 2. If that's the case, then we believe that this limit is negative 1/2. So let's go ahead and take a look at this. And this time I think I'm going to go to Desmos. Let's draw a picture of this. And we'll see what it looks like. And if our limit indeed is going to negative 1/2. Going to Desmos this time, so f of x equals. Upstairs in parentheses, x cubed minus 2x squared plus x divided by downstairs 2x cubed plus x squared minus 2x. And what happens as I get close to 0? Well, 0 is here. Interesting looking function, of course. 0 is here. So as I get closer and closer to 0, what do my y values get closer and closer to? Looks like negative 1/2. As I get closer and closer to 0, the y values get closer and closer to negative 1/2. Now the reality is 0, negative 1/2 is not really on the graph. So to clarify this, I should make it an open circle. But what happens at 0 isn't as important. What happens to the y values as I get close to 0? That's what we're interested in. That's what we're trying to look at. All right. Next question, which I think some version of this has been done in most calculus classes. The limit as x approaches 2 of x cubed minus 8 over x squared plus 3x minus 10. So our first strategy is to plug it in to see if we have an answer. If I plug 2 in for x, what do I get? 2 cubed minus 8 upstairs 8 minus 8 upstairs, 0 upstairs. If I plug in 2 downstairs, what do I get? 2 squared plus 3 times 2 minus 10. 4 plus 6 minus 10, 0. So if I have a 0 over 0 case, then I have a chance to be able to factor this. So that's what we're going to try to do. And we'll see if something divides out. So we get the lim as x approaches 2. We want to factor the top, we want to factor the bottom. Well, how do we factor the bottom? The bottom is the easier one. So we have x squared plus 3x minus 10. I like using this multiplication box to factor. X squared here, minus 10 here, plus 3x there. So we get x times x, we get plus 5 times minus 2 plus 5x minus 2x. So the result is x plus 5x minus 2. That's on the bottom. On the top, I have x cubed minus 8. So maybe you remember how to factor a difference of 2 cubes. Maybe you do. One of them will be x minus 2. Cube root of x cubed is x. Cube root of 8, of negative 8, is minus 2. So it's x minus 2 times something. The question is, do you remember that something? I'll show you the technique I use to factor a difference of 2 cubes. So I have x cubed here. I have minus 8 there. I know this is going to be x because the cube root of x cubed is x. I know that's going to be minus 2. And then x times what is x cubed? Of course, this has to be x squared because x times x squared is x cubed. Negative 2 times x squared is negative 2x squared, but I need those to divide out or cancel, subtract out. So if that's negative 2x squared, I need this to be positive 2x squared. X times what is positive 2x squared? How about positive 2x? Positive 2x times negative 2 would give me negative 4x. I need that to subtract out, so I need positive 4x here. X times what is positive 4x plus 4? 4 times negative 2 is negative 8. That checks. So I get x minus 2. So we get x minus 2 times x squared plus 2x plus 4. So that's what goes on top. X minus 2 times x squared plus 2x plus 4. Now there's the good news. The x minus 2's divide out. X minus 2 goes away. So now the result is the limit as x approaches 2. Upstairs we have x squared plus 2x plus 4. Downstairs we have x plus 5. So at this point we're going to plug in the values and see what we get. Plugging in the 2 upstairs, we get 2 squared plus 2 times 2 plus 4. Plugging in the 2 downstairs, we get 2 plus 5. And we get 4 plus 4 plus 4. 2 plus 5 is 7. 4 plus 4 plus 4 is 12 sevenths. So let's check this on the graphing calculator and see what we get. Clear that one out. Upstairs, I have x cubed minus 8 in parentheses. X cubed minus 8. Divided by downstairs, I have x squared plus 3x minus 10. And we want to see what happens as we get close to 2. So let me go to my table, close to 2, 1.9, 1.99, 1.999. So 1.9999. So 1.7142, whatever that is, 2.1, 2.01, 2.001. So again, about 1.714 in that neighborhood. What do we think 12 sevenths is? 12 sevenths. Looks like that is 1.714. So that makes me feel pretty good about that.